Welcome everyone to Future Forward, the podcast where we dissect the bleeding edge of technology and its impact on business. Today, we're diving deep into something straight out of science fiction, or perhaps, soon, straight out of Hollywood, movie-grade talking character synthesis. We have an incredible panel of experts with us today. To kick things off, let's set the stage. We've seen impressive video generation lately, but characters often feel, well, a bit mute or puppet-like. What's the specific challenge MoCha, this new framework we're discussing, is trying to solve?
From a business perspective, the demand is enormous. Think democratizing animation, film production, even creating hyper-personalized advertising or truly interactive virtual assistants. Current tools either generate pretty scenes with gesturing mannequins or give you a talking head, basically a fancy Zoom call. Neither tells a story effectively.
Exactly, technically, the gap is huge. Generating visually stunning video is one thing. Models like Sora are getting there, but making characters speak convincingly, with synchronized lip movements, natural expressions, and full-body actions driven by that speech, that's a whole different beast. It requires tight integration of modalities.
And the data landscape reflects this difficulty. We have massive text-to-video datasets, but high-quality video annotated with precise speech and corresponding actions. That's much rarer. It's like having libraries full of silent films versus talkies.
We've seen attempts, right? Talking head models like SadTalker or Emo are interesting, but they often rely on a reference image and are confined mostly to the face. They don't handle complex scenes, body movement, or interactions naturally. They're pieces of the puzzle, not the full picture MoCha seems to be aiming for.
So MoCha steps in, defining this new task, talking characters, not just heads but full portraits, potentially multiple characters driven by text and speech. Expert 2, can you unpack the core architecture? They mention using a diffusion transformer or DiT. Why is that significant?
Well, moving to a DiT architecture, similar to some recent large video models, is a big step. Unlike the UNet architectures common in many image and some video diffusion models, transformers can potentially capture longer-range dependencies more effectively. For video, that means better temporal coherence across frames. But it introduces a challenge for speech sync. Traditional autoregressive models generate frame by frame, naturally linking audio snippet, I to video frame I. DiTs often generate frames in parallel after temporal compression by a VAE, which is faster but breaks that inherent synchrony. Your video token might accidentally listen to the wrong part of the speech.
So speed and parallel processing create a lip sync problem. How does MoCha address that? They propose something called speech-video window attention. Sounds specific.
It is, and quite clever. Think of it like a musician reading sheet music. You don't look at the entire score at once. You focus on the current measure and maybe glance slightly ahead or behind for context. This window attention forces each video token, representing a compressed moment in time, to only pay attention to a small, relevant window of audio tokens around its corresponding time.
It's a localized constraint ensuring the lip movements generated for a specific moment are primarily influenced by the phonemes actually being spoken at that moment, plus a little context. It restores that crucial local alignment that parallel generation disrupts. It's not quite rebuilding the engine while driving, but maybe tuning the instruments precisely while the orchestra plays.
Nice analogy, Expert 3. Let's talk data then. You mentioned the scarcity of speech-labeled video data. How does MoCha overcome this? They mention a joint training strategy.
Yes, this is critical. They train MoCha on both the limited speech-labeled video data ST2V and much larger text-only video datasets T2V. About 80% ST2V and 20% T2V, according to the paper. When T2V data is used, the speech input is essentially zeroed out.
That sounds like a smart hedge. You get the specific speech sync learning from the specialized data, but the broader visual understanding, scene composition, and action diversity from the massive T2V datasets increases generalization, I'd imagine, reduces the risk of overfitting to just talking heads.
Precisely, it allows the model to learn a much wider range of actions and environments described via text, even if those specific actions aren't heavily represented in the speech-labeled subset. It makes the model more versatile. They also use a multi-stage training approach, starting with close-up shots where speech-video correlation is strongest, then gradually adding medium shots and more complexity, like learning scales before tackling a concerto.
This joint training is a common theme in large model development now, finding ways to leverage diverse data sources. It's a practical heuristic. Don't let the perfect be the enemy of the good. Use the gold standard data you have, but augment it smartly with more abundant, less specific data.
Let's bring in Expert 5. From a practical standpoint, maybe an animator or filmmaker's perspective, what other features stand out? They mention multi-character conversations. That seems like a leap.
It absolutely is. Most generative tools struggle with consistency, especially with multiple characters. Having person A suddenly look like person B mid-scene is a common failure mode. MoCha uses character tagging within the prompt, like defining person 1 and person 2 with descriptions up front, then referring to them just by the tag in scene descriptions. This structured prompting sounds incredibly useful. Instead of repeating, the woman with short brown hair wearing a blue sweater, every time, you just say, person 1 speaks. It simplifies input and, crucially, helps the model maintain character identity across cuts or turns in a dialogue. The paper suggests self-attention across video tokens helps maintain this consistency.
And importantly, they achieve this multi-clip, turn-based dialogue without explicit markers for cuts, relying on the change in speaker in the audio signal itself to guide the transition. That's quite elegant if it works reliably.
It's elegant, yes, but I wonder, is relying only on the audio for cuts sufficient for truly cinematic control? Film editing uses cuts for pacing, emphasis, reaction shots, not just when the speaker changes. It feels like a potential limitation for complex narratives. We might need more explicit directorial controls down the line.
That's an interesting point, Expert 6, a potential gap between the tech demo and complex cinematic language. Let's park that thought. Expert 4, MoCha was evaluated against models like SadTalker and Halo 3. What did the results show?
The paper presents MoCha Bench, a new benchmark tailored for this talking characters task, including close-ups and medium shots with actions. Quantitatively, MoCha showed superior lip-sync scores, Sync-C and Sync-D metrics. Qualitatively, and perhaps more importantly based on the human evaluations, MoCha significantly outperformed the baselines across all 5 axes: lip-sync, facial naturalness, action naturalness, text alignment, and visual quality. Scores were approaching 4 out of 4, meaning near indistinguishable from real video in many cases, according to the evaluators. Baselines often struggled with stiff expressions, limited body movement, or visual artifacts, especially in medium shots with actions.
And that action naturalness score is key. Getting a score of 3.82 versus 1 for SadTalker, AniPortrait, highlights the leap from just moving lips to animating a character performing actions while speaking. That's where the storytelling potential really unlocks.
Okay, impressive results. Expert 1, let's circle back to the business side. Assuming this tech matures, what are the killer applications and what are the hurdles?
Killer apps, personalized education modules with engaging instructors, dynamic NPCs in games that truly converse, low-cost, high-quality animation for indie creators or marketing departments, virtual influencers or customer service avatars that feel more human. The potential market is vast. As the paper notes, automating film production has immense commercial potential. Hurdles? Oh, plenty. Scalability and cost. Training a 30 billion parameter model isn't cheap. Workflow integration. How does this fit into existing creative pipelines? Control and iteration. Creatives need fine-grained control, not just a one-shot generation. And then there's adoption, overcoming the uncanny valley and ensuring audiences accept these synthetic characters.
I agree on the control aspect. The character tagging is good, but professionals will want to tweak expressions, timing, specific gestures. Right now, it seems more like casting a digital actor and giving them a script, less like detailed animation control. It's amazing, but maybe not replacing Pixar's pipeline tomorrow.
Technically, maintaining temporal consistency over longer durations, beyond the 5.3 seconds mentioned, is still a major challenge for all video generation models. Extending this level of quality to minutes, let alone feature length, requires further breakthroughs.
We're painting a picture of incredible potential but significant remaining challenges. Expert 6, you raised a point about cinematic control earlier. Any other contrarian thoughts or unexpected angles we should consider?
Well, here's a thought. Everyone is laser-focused on realism and lip-sync perfection. But what if the real bottleneck isn't the fidelity of the talking, but the substance of what's being said and the purpose it serves? We're building incredibly sophisticated digital puppets. But who's writing the compelling plays for them? Is the primary use case going to be automating existing human performances or creating entirely new forms of interaction and storytelling? I worry we might get obsessed with the technical polish, the perfect sync, the micro-expressions, and miss the bigger picture of how this fundamentally changes creative workflows or even what constitutes content.
That's a fascinating counterpoint. Are we building better tools for existing jobs, or tools that will create entirely new industries and perhaps devalue certain skills? Expert 1, any reaction?
It's a valid concern. New technology always disrupts. Automation in film could lower costs and barriers, enabling more diverse voices, or it could centralize power further with those who control the best models and data. Strategically, businesses need to think about how to leverage this for augmentation and creating new value, not just cost-cutting replication. It's like when desktop publishing arrived, it didn't kill graphic design, it changed it.
And on the data side, related to Expert 6's point, the models learn from the data we feed them. If the training data primarily shows certain types of characters, expressions, or interactions, the generated output will reflect those biases. Ensuring diverse and representative training data is a huge, ongoing challenge, especially for nuanced human behaviors.
The evaluation itself needs to evolve too. Metrics like SyncC are useful, but they don't capture emotional resonance or narrative impact. Human evaluation helps, but it's subjective and expensive. We need better ways to measure if these characters are genuinely engaging, not just technically accurate.
So many layers to this. Let's look ahead. What are the next technical milestones for MoCha or similar technologies? Where does research go from here?
Longer duration, definitely. Higher resolution and fidelity, always. More nuanced control over specific aspects like gaze direction, subtle emotions, maybe even interaction between generated characters beyond simple turn-taking. Integrating this seamlessly with broader scene generation is also key, placing these talking characters convincingly within complex, dynamic environments generated by models like Sora, perhaps.
Improving the data pipeline is perpetual. Better automated annotation, finding ways to capture more diverse co-speech gestures and body language. Also, potentially reducing the reliance on massive curated datasets through more efficient training or better transfer learning.
From a user perspective, interactivity. Imagine being able to direct the character's performance in real time or giving feedback like, make her look more concerned, and having the model adjust. That level of intuitive control would be game-changing for creators. Right now, it's prompt, generate, hope for the best, repeat. Reminds me of dealing with some actors, actually.
A little humor there, Expert 5, thanks. Okay, final thoughts as we wrap up. Expert 1, what's the key takeaway for business and tech leaders listening today?
The era of truly dynamic conversational AI characters is dawning. MoCha represents a significant leap towards making this feasible beyond just headshots. Leaders need to start experimenting, understanding the capabilities and limitations, and thinking strategically about how this fundamentally changes content creation, customer interaction, and digital experiences. Don't wait for perfection, start learning now.
And consider the ethical guardrails from day one. Deepfakes, misinformation, authenticity. These aren't afterthoughts. They're core challenges that need robust technical and policy solutions alongside the creative advancements.
Powerful final words. MoCha certainly seems like a landmark step, bridging the gap between silent generated videos and truly expressive, talking digital characters. We've covered the impressive tech, the clever solutions like window attention and joint training, the challenges of control and data, and the profound business and ethical implications. My sincere thanks to Expert 1, Expert 2, Expert 3, Expert 4, Expert 5, and Expert 6 for sharing their invaluable insights today. This has been a genuinely enlightening discussion. And thank you to our listeners for tuning into Future Forward. Join us next time as we continue to explore the technologies shaping our world. You can find links to the MoCha project and related resources on our website. Until then, stay curious. This paper introduces MoCha, a new model for generating realistic talking character videos. It defines the task of talking characters generation. This task involves creating full portrait characters, not just faces. Characters show synchronized speech, emotions, and full body actions. MoCha uses only speech audio and text descriptions as input. It does not require extra conditions like reference images or keypoints. A novel technique called speech video window attention is used. This method improves lip synchronization by aligning audio and video locally. It ensures video frames focus on corresponding short audio segments. MoCha learns using a joint training strategy. It trains on both videos labeled with speech and videos labeled only with text. This approach helps the model generalize to diverse character actions and scenes. The model can generate videos with multiple characters in conversation. Structured text prompts with character tags enable clear multi-character interactions. Characters can engage in turn-based dialogues within a scene. MoCha is based on a diffusion transformer network architecture. Evaluations show MoCha significantly outperforms previous methods. Human judges rated its output highly for realism and expressiveness. The model sets a new standard for controllable, narrative-driven video synthesis. This research advances automated film production and character animation.